The next thing we need to configure for our employee directory app is the storage. Our application requires several types of storage for its data. For one, we need to store the operating system, software, and system files of our app. We also need to store static assets like photos for the employee headshots, and then we have more structured data such as the name, title, and location of each employee as well. All of that needs a home. The structured data usually requires a database, which we'll talk about later this week. So for now, we'll focus on storing the application files as well as the static content. There are two main types of storage that we can use to store this data: block and object. Here's the difference. Let's say that I have a 1 GB file with text in it. If I'm storing this in block storage, what happens is that this file is split into fixed size chunks of data and then stored. Object storage, on the other hand, treats each file like a single unit of data. This might seem like a small difference, but it can change how you access and work with your data. Let's say I want to change one character out of that 1 GB file. If my file is stored in block storage, changing that one character is simple, mainly because we can change the block, or the piece of the file that the character is in, and leave the rest of the file alone. In object storage, if I want to change that one character, I instead have to update the entire file. Let's take these two types of storage and access patterns and try to apply them to the data we want to store. For example, our static data, like the employee photos, will most likely be accessed often, but modified rarely. Therefore, storing in object storage is fine. For more frequently updated data, or data that has high transaction rates, like our application or system files, block storage will perform better. In this section of the course, we'll discuss both block and object AWS storage services and how they'll interact with our employee directory application. Before we do that, take a look at the notes to get a refresher of the different types of storage. That way you can easily match the storage type to the AWS storage service that we talk about. Thank you, and welcome back to everyone's favorite game show, which AWS storage service do I use for my use case? Today we have one contestant during the final round of our show, and that's you.
In order to win the grand prize, you must answer the next 3 questions correctly. There will also be a bonus question, so there's an opportunity to get extra points. All right, once we read the question, you have 5 seconds to answer to get points. Let's get started.
All right, this is the first question. Let's say you're a developer and you plan to build out an application to transcode large media files like videos. You'll be using an AWS Lambda function to perform the transcoding, but you need a place to store both the original media files and the transcoded media files. Due to regulations, you need to store these files for at least a year. Which of the storage services that we've talked about in this course should you use? You have 5 seconds to answer. And the answer is Amazon S3. Why is S3 the best solution here, Morgan?
Well, first of all, the question says that they're using a Lambda function. Because of that, I'm already ruling EBS out, as EBS volumes can only be attached to EC2 instances. Even if they were using EC2, video files are typically large in size, so you may have to use multiple EBS volumes to store that data, which might not be cost-effective in the long run. So EBS is out. Instant storage is out for the same reason. We're not using EC2 here, but also because we want this data to persist for a year, and instant storage is considered ephemeral.
All right, S3 it is. Let's put some points on the board for those who got it right. Morgan, tell us the next question.
The next question is, you're an architect for an e-commerce company that wants to run their MySQL database on an EC2 instance. This database needs a storage layer to store their order and customer information. The database will frequently be accessed and updated, so the storage layer needs to respond quickly. It's important that the storage is fast and durable. Which AWS storage service should you use? You have 5 seconds. And the answer is Amazon EBS. Add 30 points to your score if you got it.
It seems like we're looking for storage attached to the compute, so why not EC2 Instant Store?
Right, that's also an option, but it's not ideal. Since it's an e-commerce company, their order and customer data is what drives the business, which means the persistence and durability of that data is really important. Using EC2 Instant Store would definitely give us the speed we're looking for, but it wouldn't give us the durability needed to store this data long term. So EBS is the right option.
That makes sense. All right, moving on. 2 more questions. The next one is, you have a web application that needs to write to disk in order to perform certain calculations. The application will store temporary data during the calculation. The most important aspects of this architecture are speed and cost. With 5 seconds on the clock, which storage solution would you choose? And the answer is EC2 Instant Store.
Seth, would you mind telling us how we chose Instant Store and not EBS?
Sure. Once again, we're looking for storage attached to compute in this case. The first thing I want to point out is that this is temporary data we're talking about. We're not looking at a huge amount of data, and we also don't necessarily care about the durability of that data. If the instance fails mid-calculation and you want to plan for failure, you can just restart the calculation from scratch. So durability doesn't matter, but cost does. By not using EBS and instead using Instant Store, you may save yourself some cost. That is because Instant Store is included in the overall EC2 instance price, so Instant Store is the best option for this use case.
Okay, 30 more points on the board for those of you who got it. Now, the final bonus question for an extra 10 points is next. This is a tricky one, and you might have to think outside of the storage options that we've talked about so far. The question is, let's say you're creating a WordPress site on multiple instances. By default, WordPress stores user uploads on the local file system. Since you want to use multiple instances, you'll need to move the WordPress installation and all of the user customizations into a shared storage platform. Which storage option would you use? 5 seconds to go. And the answer is Amazon Elastic File System or Amazon EFS. This service was covered in an earlier reading, so if you got points for this, great job. For those of you who didn't, no worries, but I would recommend that you go back and review the reading related to file storage on AWS.
Let's go ahead and talk about the options. Typically, when we talk about shared storage systems that multiple instances can access, we think Amazon S3. Why wouldn't we use that in this case?
Well, S3 isn't a file system. It's actually a flat structure for storing objects instead of a hierarchy, and you can't mount it onto multiple instances. Because S3 has a different underlying type of storage, it's not right for this use case. So by moving the entire WordPress installation directory onto an EFS file system and mounting it onto each of your EC2 instances when they boot, your WordPress site and all of its data is automatically stored on a distributed file system that isn't dependent on any one EC2 instance.
Nice. Well, you answered all 4 questions and you win the grand prize of the satisfaction of getting them all right. Congratulations, and that's it for today's show. Hey everyone, welcome to our exercise walkthrough on creating an S3 bucket and then modifying the EC2 instance holding the application to utilize this S3 bucket. As you can see, I'm already in the AWS Management Console and I'm logged in as the admin user that was created before. So the first thing that I need to do is to create the S3 bucket that will be utilized by the application. To do that, I'm going to go up to this search bar here and type in S3 and then click on the S3 service to be taken to the S3 console. Now that I'm in the S3 console, I'm going to go ahead and click Create Bucket. And for my bucket name, I am going to use Employee Photo Bucket. dash SR as my initials, and then dash and just 3 random digits. So I'm going to go with 963. I do want to make sure that my bucket is in the same region as the rest of my infrastructure. So I'm going to keep this as the Oregon region, or US West 2. And then I'm going to keep all of the other defaults as they are. From there, I'll go ahead and click Create Bucket. And as you can see, my bucket has been successfully created. Now that the bucket has been successfully created, I want to test uploading an object just to make sure that it all works. So I'll click on the name of the bucket, which will take me to the bucket details page. And to upload a file, I can click this upload that's in the center of the page here, but more often I'm going to use the one in the upper right. So I'll click that upload button, and then I'll click add files, and I'll go ahead and upload this employee to a photo. After I add that file, I can click upload, and as you can see, the upload of that file was successful. So I'll go ahead and click close there. And in a previous demo, you might have seen a way to make this object publicly accessible, but for this bucket and for the exercises moving on, we don't want this bucket to be just completely open to the world. We want this bucket and these objects to specifically be accessed by the application. And so in order to do that, we need to adjust the permissions for this bucket, specifically the bucket policy. So since I'm already in the bucket details page, I'm going to go ahead and click on this permissions tab, and I want to adjust the bucket policy for this bucket. So I'm going to scroll down to bucket policy and click the edit button, which will take me to a spot where I can create a bucket policy. So to create this bucket policy, I'm going to take the policy that is in the exercise instructions and paste it here. But before I move forward, before I save this policy, I need to edit a few things. The first thing that I need to edit is the account number so that I am utilizing the correct account. And that will be done here where it says insert account number, and I will paste my account number there. And then from there, I will also scroll down and change this area where it says insert bucket name and put my bucket name there. And I need to make sure to do that in both locations, and make sure that I'm also removing the caret brackets when I do so. So now that I've done that, I can go ahead and save these changes, and my bucket policy will be created. And now my account with this specific role will have access to this bucket and the objects within this bucket. So now that I have tested uploading an object and created the bucket, as well as providing access to the bucket by that role, I need to modify the application to utilize this bucket. So to do that, I'm going to go over to EC2 and click on Instances. And as you can see, my stopped instance from previous exercise is there. And there's a cool little shortcut that can be used in order to clone this instance so that I'm launching basically the exact same thing and making sure that I maintain those settings. So to do that, what I'll do is I'll select this stopped instance, and then I'll go over to Actions and down to Image and Templates, and then I can click Launch More like this. What that's going to do is open up my instance launching page, but already have certain things filled out so that my instance is going to be a clone of the stopped instance that I've already launched. So what I want to do is make sure that I know that this is my updated application instance. So to do that, I'm going to append -s3 to the end of the instance name. So it'll be employee directory app s3. And my image and instance type are going to remain the same. So what I can do is just make sure that I'm using the same key pair that I'm using with my other instances. And then I want to scroll down and make sure that this is going to be accessible. So I want to change my auto assign public IP to enable. And that's just going to make sure that I have a public IP address to access for this instance. From there, I'm going to continue to scroll down as all of the other settings are still correct. And then I'm going to expand advanced details. With the expanded advanced details, I can see that the role is already associated to this instance. And I'm going to scroll all the way down to the user data. And what I need to do is put my bucket name in here so that now my application knows what bucket to utilize. And so with my bucket name there, I can now launch my instance. And that will just take a little bit of time. So I'll go over to my instances and I'll wait for that to be launched, just occasionally refreshing it to make sure that everything launches correctly. And I want to wait until the status check is showing 2 of 2 checks passed. So now that I've given it some time, I'm going to go ahead and click refresh again. And as we can see, there are 2 of 2 checks passed. So I just want to make sure that this application is up and running. I will select this instance and copy its public IP address. And then in a new tab, I will go ahead and paste that IP address. And as we can see, the application is up and running. We still can't interact with this application yet because the database hasn't been associated. So that is just to make sure that the application is up and running, and we'll be able to interact with it in just a bit. So now that that's been done, just want to do a couple of the closeout tasks for this. And so just make sure that you, if you're following along or if you've already done this, that you go ahead and stop this instance as well as delete the object that was uploaded to the S3 bucket. And that'll just make sure that you don't accidentally accrue any charges outside of running this exercise. All right, that's it for this one, and I will see you in the next exercise.
The employee directory application that we've been building out lets you keep track of employee data like their name, location, job title, and badges. The app supports adding new employees, viewing existing employees, as well as editing and deleting employees. All of this data will be stored in a database, which we haven't created yet. According to the architecture diagram, we have chosen Amazon Relational Database, or Amazon RDS, to store this data. So let's talk about databases for a moment. Relational databases are widely used across all industries, and it's likely your company has many databases supporting a variety of applications and solutions. Relational Database Management Systems, or RDBMS, let you create, manage, and use a relational database. You can install and operate database applications on Amazon EC2 instances, and this is a good option for migrating existing databases to AWS. By running databases on EC2, you are already simplifying things from an operational perspective when it comes to on-premises, and it's a common use case for EC2. When migrating a database from on-premises to EC2, you are no longer responsible for the physical infrastructure or OS installation, but you are still responsible for the installation of the database engine, setting up across multiple AZs with data replication in place, as well as taking on any database server management tasks like installing security patches and updating database software when necessary. So EC2 makes it easier, but there is a way to lift even more of the operational burden of running relational databases on AWS. What if instead of managing a database on EC2, you could use one of the managed AWS database offerings like Amazon RDS? The big difference between these two options is instead of taking care of the instances, the patching, the upgrades, and the install of the database, AWS takes care of all of that undifferentiated heavy lifting for you. The task that you are then responsible for is the creation, maintenance, and optimization of the database itself. So you are still in charge of creating the right schema, indexing the data, creating stored procedures, enabling encryption, managing access control, and more. But all of the rest of the undifferentiated heavy lifting that goes into operating a relational database, AWS takes care of. To start off this section of lessons on databases, we will first cover RDS. The upcoming reading after the video will dive into the history of enterprise relational databases and explain what relational databases are and how they were used. If you aren't familiar with databases, the readings coming up will give you some useful background information. Amazon RDS is a service that makes it easier for you to set up, operate, and scale a relational database. Instead of telling you about RDS, I am going to show you. As you can see, I'm already in the Amazon RDS dashboard. We are going to create the relational database our employee directory application can use to store employee data. First, we will click Create Database. And then we are going to select the Easy Create option, which gives us the ability to accept the standard best practices for backups and high availability. You could select Standard Create if you wanted more granular control to pick and choose the different features of your database setup. Next, you choose the database engine. You can see what is currently supported at the time of this filming for database engines on RDS. And the common engines out there are MySQL, PostgreSQL, MariaDB, Microsoft SQL Server, and then there's this one, Amazon Aurora. Amazon Aurora is an AWS-specific database that was built to take advantage of the scalability and durability of the AWS cloud. Aurora is designed to be drop-in compatible with MySQL or PostgreSQL. It can be up to 5 times faster than the standard MySQL databases and 3 times faster than standard PostgreSQL databases. So if you have some use cases that require large amounts of data to be stored with high availability, durability, and low latency for data retrieval time, consider using Amazon Aurora over a standard MySQL or PostgreSQL RDS instance. In our case, we really only need a simple database without any high performance or large storage requirements. So I'm going to select a standard MySQL instance. Next up, we will choose the database instance size and type. This database instance is similar to how we choose an EC2 instance size and type. Since this is just a demo, I'm going to select a free tier eligible instance. Now we'll give this database a name and assign the database an admin user and password that would be used to connect to the database. Then we will accept the rest of the Easy Create defaults and we are done with this instance creation. You can see that the instance is in the process of booting up, and that will take a few minutes to complete. So in the meantime, let's talk about high availability and RDS. When you create an RDS DB instance, it gets placed inside of a subnet inside of a VPC very similar to an EC2 instance. As you learned already in a previous lesson, subnets are bound to one AZ. And as a best practice for production workloads, we recommend that you always replicate your solutions across at least 2 AZs for high availability. With RDS, one DB instance belongs to one subnet inside of one AZ. So that isn't meeting the criteria for best practices. Now, before you get worried about managing this all on your own, just know that you can easily configure RDS to launch a secondary DB instance in another subnet in another AZ using RDS multi-AZ deployment. And RDS will manage all of the data replication between the 2 instances so that they stay in sync. The other cool thing about RDS multi-AZ deployments is that RDS also manages the failover for the instances. One instance is the primary, and the other is the secondary database. Your app connects to one endpoint. If the primary instance goes down, the secondary instance gets promoted. The endpoint doesn't change, so no code change is needed. All of the failover happens behind the scenes and is handled by RDS. All you do need to do is to make sure that your app can reconnect to the database if it experiences a momentary outage by updating any cache DNS lookups and reconnecting to the endpoint, which now connects to the secondary instance. Pretty cool if you ask me. All right, and we're back in the console and we can see that our instance is up and running. At this point, you can connect to the database instance and load your database schema onto it, ready to go, and much, much simpler than trying to install and manage this all on your own. Using services like RDS make operating databases significantly more accessible and lowers the operational overhead that comes along with relational database management. Before we move on to learning about Amazon DynamoDB, I want to touch on an idea that's important when you're making architecture decisions for your AWS solutions. Choosing the right database to fit your business requirements rather than forcing your data to fit a certain database choice. There is no one-size-fits-all database for all purposes. You should pick a database that fits your specific use case, and with AWS, you have multiple choices for databases. We covered Amazon RDS and relational databases, and that was the default option for businesses for a long time. But relational databases aren't the best choice for all business needs. AWS creates services to support purpose-built databases, meaning that there are many database services that AWS offers, and they each were built with a certain use case in mind and therefore are optimized for those use cases. Let's think about the Employee Directory app. We had originally decided that we would use RDS for the database, but now, after thinking about it some more, RDS might not be the best fit for our needs. All we are really doing is storing one record in a table for each employee. There are no complex relationships that need to be managed, and it's essentially just a lookup table. Relational databases offer all sorts of features that are great for complex schemas and relationships, but those features add overhead that is unnecessarily complex for simple things like a lookup table. On top of that, the RDS option we chose charges per hour of instance runtime, so we will get charged for the running instances regardless of whether we're using it or not. Our employee directory application will have much higher usage during the week and no usage on the weekends. Is there an AWS database offering that better fits our needs? Introducing Amazon DynamoDB. Amazon DynamoDB is a NoSQL database that is great for storing key value pairs or document data. This service works great at a massive scale and provides millisecond latency. It also charges based on the usage of the table and the amount of data that you are reading from the table, not by the hour or by the second. This is a better option for our simple employee lookup table. Now, besides the employee directory app, there are other use cases that require databases of varying types. What if you are writing an application that needs a full content management system? Neither RDS nor DynamoDB would be the best solution. Luckily, AWS has quite a number of other database offerings. For this use case, you might look into Amazon DocumentDB. It's great for content management, catalogs, or user profiles. Let's think of another use case. What if you had a social network that you wanted to track? Keeping track of those kind of social webs, figuring out who is connected to who, can be difficult to manage in a traditional relational database. So you could use Amazon Neptune, a graph database engineered for social networking and recommendation engines, but is also good for use cases like fraud detection. Or perhaps you have a supply chain that you have to track with assurances that nothing is lost, or you have a banking system or financial records that require 100% immutability. What you really need is an immutable ledger. So perhaps Amazon QLDB or Quantum Ledger Database is a better fit for this use case. It's an immutable system of record where any entry can never be removed and therefore is great for industries that need to be audited for regulatory and compliance reasons. It can take a lot of experience and expertise to operate databases at scale, and that's why it's so beneficial to utilize one of the AWS database offerings. You don't need to be an expert on running all of these different types of databases. Instead, you can just use the database service that is best for your use case and focus on your application and providing value to your end users. You don't need to build up a ton of in-house expertise to operate a highly scalable, immutable ledger database. You can just use AWS QLDB instead. The key thing to understand is AWS wants to make sure that you are using the best tool for the job. Coming up next, we will explore Amazon DynamoDB and get a look at more of the details. Let's talk some more about Amazon DynamoDB. At the most basic level, DynamoDB is a database. It's a serverless database, meaning that you don't need to manage the underlying instances or infrastructure powering it. With DynamoDB, you don't create a database with tables that relate to each other like a relational database. Instead, you create standalone tables. A DynamoDB table is just a place where you can store and query your data. Data is organized into items, and items have attributes. If you have one item in your table or 2 million items in your table, DynamoDB manages the underlying storage for you, and you don't need to worry about scaling the system up or down for storage. DynamoDB stores data redundantly across AZs and mirrors the data across multiple drives for you under the hood. This lessens the burden of operating a highly available database. DynamoDB, beyond being massively scalable, is also highly performant. DynamoDB has a millisecond response time, and when you have applications with potentially millions of users, having scalability and reliable lightning-fast response times is important. Now, DynamoDB isn't a normal database in the sense that DynamoDB doesn't require a rigid schema or manage complex relationships or constraints. Relational databases, like the MySQL database we created in an earlier lesson, require that you have a well-defined schema in place that might consist of one or many tables that may or may not relate to each other. Relational databases work great for a lot of use cases and have been the standard type of database historically. However, these types of rigid SQL databases can have performance and scaling issues when under stress. The rigid schema also makes it so that you cannot have variation in the types of data that you store in a single table. So it might not be the best fit for a data set that is a little bit less rigid and is being accessed at a high rate. This is where NoSQL databases like DynamoDB are handy. NoSQL databases have flexible schemas. With DynamoDB, you can add or remove attributes from items in the table at any time. Not every item in the table has to have the same attributes. This is great for datasets that do have some variation from item to item. The types of queries you can run on NoSQL databases tend to be simpler and focus on a collection of items from one table, not queries that span multiple tables. This, along with other factors, including the way the underlying system is designed, allowed DynamoDB to be very quick in response time and highly scalable. So, things to remember. DynamoDB is NoSQL. It is purpose-built, meaning it has specific use cases and isn't the best fit for every workload out there. Taking a look at our architecture, we modified it to use DynamoDB. We're going to need to create an employee table for the app to write and read from. We will create this DynamoDB table using the console. And you know what? Let's get Seth out here to help us out.
Hello!
We changed our minds about using RDS and decided to change it over to DynamoDB. It's only one table, and it's essentially a lookup table for our employees. How hard do you think this change is going to be to make?
Well, our app is actually designed to use either RDS or DynamoDB as the backend database, so this won't take long at all. Here, I'll show you how. I'm in the console and will navigate to the DynamoDB service. From here, all you need to do is create a new table. Tables in DynamoDB require you to designate certain attributes as keys that will make an item unique. We will select employee ID as the unique identifier for the items in this table. Then we will just accept the defaults and create the table. Our app was coded to look for a table specifically called employees. So this actually should all work now that the table is created. To test it out, let's head over to the website hosted on EC2 and try to add a new employee. See, that was nice and easy. Now let's go back into DynamoDB and refresh the page and scan all the items in the table, and boom, there it is. It's really that simple for a lookup table like this one.
All right, well, that was easy. Nice. Now, not every use case is this simple. In the reading after this video, there will be more information about how DynamoDB works, so make sure to check that out.
Welcome to our exercise on setting up the database for our application. So we've already created and modified the application and have created and tested the uploading to the S3 bucket. So to get the application fully functional or at a fully functional stage, the next thing to do is to launch a database. But before I launch the database, I want to launch an instance that's ready to use that database so that we can test it as soon as it's done. So to launch that instance, I'm going to go over to EC2 and go over to the instances. And just like with the last time, I'm going to use the shortcut where I launch a clone of an instance that I've already launched. So to do that, I'm going to select my employee directory app-s3 because that's the most updated version of this application. And then I'm going to go over to Actions, Image and Templates, and then I'm going to launch more like this. Now that I'm in that launch page, what I want to do, just so that I know that I am on the correct instance and that I'm using the correct instance, instead of appending -s3 to this, I'm going to append -dynamodb so that I know that this is the application instance that is testing with the database and not just connecting to the bucket. So now that I've adjusted that, I can scroll down. I see that most of my settings are still there. I want to make sure that I'm still using the same key in case I do need to access the instance. And I also want to just verify, even though I know that this works, I just want to verify that I am still using the role. One other thing that I want to make sure to do is to ensure that the instance launches with a public IP, and I scrolled just right over this. And so scrolling back, I go to the network settings and auto assign public IP, and just make sure that I click enable on that. And that way the instance will have a public IP and I can access it and test it once the instance and the database are all fully launched. So now that I've done that, I can see that my user data is exactly where I left it after adding the bucket. And now I can click Launch Instance. As always, give that some time to launch. And I can just go over to the instances and occasionally refresh this in order to make sure that my instance has launched. So I'm going to give this a few minutes while waiting for the instance to launch and making sure that where it currently says initializing, it will say 2 of 2 checks passed. Now that it's been a few minutes, I'll go ahead and refresh the page again. And I can see that 2 of 2 checks have passed. So I'll go ahead and select my DynamoDB labeled instance and copy its public IP address, just because I want to make sure that the application is up and running before I proceed. If this weren't running, as we can see it is, if it wasn't, then I would go back and see where I made a mistake in launching the instance. And once the application was successfully running, then I would move forward with creating the database. And so since I can see that the base employee directory application is up and running, I can go ahead and proceed with creating the DynamoDB table. In order to do that, I'm going to go up to the search bar and type in Dynamo and click on the DynamoDB service. And once I'm here, I'm just going to go ahead and click Create Table. Since I don't have any tables currently running, it's just the easiest way to get to this table creation screen. For the table name, I'm going to put employees because the application is set up to work with a database named employees. So this will make it very easy for it to just utilize this. And then for my partition key, I'm going to put ID. And this is because, again, the application is set up to utilize this for organization within the table. And then I'm going to keep this type as a string. After I've done that, all of the default settings can remain, and I'll just go ahead and click Create Table. And that takes just a little bit of time, and the table will be created in just a bit. So I'll just give it a couple of seconds here. So that took almost no time at all, and the table has successfully been created. So now that the table is created, instead of adding items directly to this table, what I want to do is test the application again. So I will make sure I copy my instance's public IP address. So I'll go over to my instances and select the instance that was launched for this and copy its IP address. And then in a new tab, I will paste that address, and I can see that the employee directory app is still running, and it is currently an empty directory. But I can go ahead and add an employee to this directory just to make sure that everything is connected. So what I'll do is I'll click Add, and I'll go ahead and put my name here, and then my location, and my job title. I'll also just select a couple of these options here, just so that we can see what it looks like as everything is added to this table and added to this directory. So since I am a Seattle resident, I am also very much a Seattle fan, and I'm very definitely a coffee snob. I will also not just put this information into the table, but I will add a file. I'll add my employee photo and open that up. And then once that has all been added, I can go ahead and click Save. And as we can see, I now have an entry in the employee directory. So it looks good here, and we can see that I am now in the directory, but I want to show that this isn't just something that was added to this location. So what I will do is show that these items were added in the table and in the S3 bucket. So starting with S3, I'll go over to S3. And then I will open up the bucket that I had created. And as we can see, my employee pic has been added, and it's the employee picture that I uploaded. Even though it has its own designated name here, this is the object that was uploaded through that application. And then I can also go over to DynamoDB and can view my table and view my employee table and explore the table items. And I can also see that my employee items that were added through the directory are here. And so it shows which badges I associated with myself, my name, my job title, my location. It shows the name of the object that was uploaded through the directory, and it shows the ID specifically for this table and the partition key that we established. So now that all of that has been done, what I want to do is just go ahead and keep the table running, but I want to go back to EC2 and stop the instance so that I'm not accruing any additional charges as I prepare to move on to the next stage of this application infrastructure development. So I'll go ahead and stop that instance, and that's where I'll go ahead and close this walkthrough out, and I'll see you in the next one.